So thank you very much for organizing this fantastic symposium to Misato. And first of all, I'd like to say thank you very much for giving me the opportunity. My recent progress of my recent research regarding for the evolutions of the languages, evolutions of the grammatical rules. So I am Hiroki Koda from the Primate Research Institute, Kyoto University, the same universities of the Misato and the same university of the Professor Tetsuro Matsudawa. So today, I'm mainly focusing on the grammatical evolutions, comparing the human languages and their given song syntax, okay? And also, I'd like to say some my colleagues listed here, okay? Okay, as a kickoff of my talk, I first show you the sample video clips of the given songs, like that. So this is Sherman, a species of the gibbon. So Sherman produced so complex and so loud and so fantastic songs like that. Oh, wow, so loud. It reaches 2 kilometers in the forest, in the canopy. Oh, 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 oh. Actually, I'm a best mimicker of the given song. Oh, 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 like that. So actually, I'm a best mimicker of the given songs. Actually, in the do's, in front of the givens, I try to mimic this sort of the songs. I always successfully get the song replies from the Shermans or the other gibbons, okay? In other words, it means I can simulate the rules of the given songs, just like naturalistic rules of the given song. So what happens in my brain? How can I simulate the rules of the given songs? Actually, it's a main topics to be discussed here today in my talk, okay? So now I raise a simple question, okay? How do animal songs differ from the human languages? How do you think about that, these issues? Symbols, vocal learnings, otherwise the tool using? How do you think about that? Of course, different researchers have the different perspectives, different ideas, different opinions. Of course, I know. But this symposium topics is hierarchical. So today, I targeted on these issues as grammatical rule evolutions underlying both animal songs and human languages, like that. Okay, next, what is grammatical rules? Before the details of my talk, I first define the grammatical rules. Let's see. Now I see you the simple string pattern A, B, Y, Z. Okay, how do you feel this sequence pattern of the 4 strings? More precisely, how is it generated? More precisely, what is the grammatical rules underlying these sequence generations A, B, Y, Z? How do you think? Can I solve these issues? Okay. Some people think that look like this. First, animal start state Q1, okay? Animals always start from this Q1 state. Actually, this Q1 state generates the string A, and after generating the A, the Q1 state transit to the next state Q2, and actually this Q2 state generates the string pattern B, and like that, and transit to 3, and Q3 generate Y, Z, finish. It's one of the example of the models generating these string sequences A, B, Y, Z. It's one of the possibility generative rule. In this rule, always the state is connected to the previous state linearly. So now we call this rule is as a linear grammar model, okay? Linearly connected, okay? But of course, the other guy have the another possible model like that. Animals start from the Q1 just like linear models, but actually this state generate a set of the A and Z. After the generating the pair of the A and Z, the Q1 state transit to the Q2, and actually the Q2 state generating a pair set of the B and Y. Actually, in these rules, A, B, Y, Z pattern was also generated, also simulated. In these models, importantly, in this model includes a hierarchical structure. So now we called this model as hierarchical grammar models. Okay, now we have the two different models simulating the A, B, Y, Z. One model is linear grammar, and another model is hierarchical grammars. Of course, different models have the different advantages and the different disadvantages. What is that? For example, in the linear grammar, advantage is no large memory spans. It means that, for example, the Z always depends on the Y depends on the B, and the B depends on the A. Actually, the all state depends on the previous state. So, actually in these models, we don't need memory span. This is an example of the sentences. Cedric didn't come, but Mitchell came. Actually, we can't forget that Cedric didn't come, okay? It's one of the examples for the advantages for the linear model. But for these advantages, in this model needs many states and many transition patterns, okay? By contrast, in the hierarchical models, Z depends on the A, okay? Y depends on the B. So the example sentence is Michiru who was not planned to come, okay? Actually, we shouldn't forget the Michiru to accept the termination of the sentences come, okay? Always Z depends on the A, and always depends on the Y depends on the B. In this hierarchical models, solve us to simulate the center embedding structures of the sentences, okay? But this model needs memory, okay? We shouldn't forget the Michiru after accepting the end of the termination of the sentences, okay? This is a compact but need a memory span. Okay, to summary. Hierarchical model needs compact, enable us to the compact analysis, but need memory span. But the linear models is so complex, but don't need any memories. Actually, this is one of the fundamental boundaries between the animal song models and the human language models proposed by the Chomsky, okay? This is the hierarchical models proposed by the Chomsky, so-called as the context-free grammars. It's so unique for the human languages, but this is an example of the linear models representing for the Bengalese finches songs. Actually, the Bengalese finches song is generated by the finite state grammars, linear grammar. Actually, this center embedding processing structure is the fundamental gap between the human language grammar and the animal song grammars. Okay, but is it really? So here we back to the given song analysis, our target. We do grammatical analysis of the given song to find the possibility of the hierarchical structure by using the big data and by using the computational analysis of the animal song, okay? So, again, I try to set simple questions. Which one, linear or the hierarchy rule, is better to explain the song patterns of the given song? This is our main target to be tested here, okay? So, to test this question, we performed recording the big data, massive data of the given songs, and construct the computational model to fit and predict the sequential rule of the given song. To do so, we set up the microphone with the small computer server. It's always recording, continuously recording in the PRI, and all recording data automatically uploaded in the server, set it in my office, and always access their songs, at least from the 3 subjects. And in this analysis, we used around 6,000 song frames. But this 6,000 recorded only 1 week. Of course, now I always access their data so that freely available to analyze and record the many song frames, okay? So first, I computationally fit the song data by the hierarchical models. So more precisely, context-free grammar models, okay? Important evidence is that actually the linear grammar is a subclass of the context-free grammar. So in this analysis by the fitting by the context-free grammar, we can classify the types. I mean the hierarchical structure or the linear structure, okay? We can classify the types only by the context-free grammar models, and we can evaluate the presence of the hierarchical song structure included in the given data. This is the result, okay? Pie chart represents the percentage of the 2 class, hierarchy or the linear class. Importantly and interestingly, majority of the data comes from the hierarchy class, blue one, around over the 70%. Okay? This is an example songs classified as a hierarchical structure like that. Oh, I couldn't recall playback. Okay, I imitate. Like that. Actually, that we perceive that the subclass of the structures and combined, I believe that. In contrast, the example of the class of the linear types sounds like that. Like that. It's monotonically changing the strings. It's like linear structures, okay? Anyway. Fitting by the context-free grammar model revealed that majority of the data comes from the hierarchy structures. Okay. So, our conclusions, tentative conclusion, we got, okay, given songs comes from the hierarchy grammar model. Hierarchy grammar model generates given songs. Okay, great, fantastic. Really? Actually, I don't think so, actually. Okay, actually, this is too early to say because Actually, we independently fit the data only by the regular models, linear models, not using the context-free grammar types, okay? Only the linear models, like a hidden Markov model. It's a so popular models as the linear models. So what's happening fitting only by the linear models, okay, to compare, to test the probability, posterior probability of the two models, okay? Actually, this is the next result. This is the posterior probability of the two models. It's just like predictive powers, just like fitting scores of the two models. Interestingly, two models, hierarchical models and linear models, equivalent. In other words, linear models could enough explain the sequential patterns of the given songs. More precise, more simply. Linear models is good enough to predict the complexity of the sound sequences. Okay, what's happening? How do you think? Actually, linear model is very complex. Many states and many transition patterns, okay? Many states and many transitions. Okay, let me summarize my findings. Fitting by the context-free grammar, hierarchical models leave many hierarchical types of songs. It suggests many chunk phrase-like structures included in the given songs. However, linear model is good enough to predict the song sequences. It means if we prepare the complex linear model pattern, it's good enough to predict the given songs. Okay. This is our tentative conclusion with the evolutionary views. Okay? Actually, hierarchical structure has already pre-adaptively set up in all of the animal signal sequences, all already set up, just like pre-adaptations, but it is unclear for animals to process correctly these hierarchical structures. So my opinion, after hierarchical sequence emergencies, okay, hierarchical sequence processing would evolve only in the human lineages. So take-home message is like that. Emergency is the first and the cognition is the next in the human lineage. Thank you very much.